Today we'll talk about the difference between a spike and a square pulsar and exactly what is the pulse width. On your ultrasonic instrument, you've got a pulsar which sends a signal to the transducer. It's probably a unipolar pulsar, which means that it's going to send just a negative voltage signal, and you usually have the opportunity to choose between spike or square. The pulsar works in concert with the voltage. The higher the voltage we get, the more oomph we get from the signal, at the expense of using more battery power and maybe a little bit more wear and tear on your transducer. If you select spike, it sends a very short negative voltage spike to the transducer. Now, it's not infinitesimally short. It does take a very short amount of time to rise and a little bit longer to fall. But for the purposes of illustration, we'll consider a spike short and sharp. Another way to think of a spike pulsar is like a drummer hitting a drum. Imagine taking the drumstick, coming down, hitting the top of the drum head. There's a very short impact time, just like a spike. That drum head's going to resonate at its natural frequency. And assuming that you've tuned the snare drum and you haven't purposely broken things, it won't sound like crap.
Rock and roll, St. Anchor, that's simple.
With square wave, we send that negative voltage and then we hold it for a certain amount of time. If we get that time to be half of the period of the waveform, this then forces the crystal to flex in that one direction in tune with its natural frequency, and we end up getting the most sound power out of it. With a square pulsar, the drumming analogy kind of falls apart, but imagine the stick is able to come down and hold on top of the drum head. Then you release the stick and the drum head tension pulls itself back up, maximizing the amount of bounce or amplitude. This in turn makes the drum sound louder. Now, we can't really ask a drummer to do that, but we can certainly get the instrument to fire a square wave. Pulse width is how long we hold that negative square signal. And to get the most amount of sound power out of your transducer, you want to set this to half the period. Period is the inverse of frequency. Frequency is cycles per second, so period is seconds per cycle. For a 5 megahertz transducer, the period is the inverse of that, so 1 divided by 5 million is 0.0, a bunch of zeros, and then a 2, that's 200 nanoseconds or 200 billionths of a second. That's the entire period, so the setting for the pulse width should be half of that, or 100 nanoseconds. If you go longer or shorter than that, then you're basically forcing the crystal to do something that it really doesn't want to do. Here's a photoelastic video from Ed Ginzel showing what happens to a pulse from a 5 megahertz transducer if you set your square wave pulsar to different values. Notice the intensity of the image is best at around 5 megahertz, and then it gets weaker as we go higher. For very special applications or very attenuative materials, you may find that you have to use a square wave pulsar. But for most cases, it doesn't really matter. If you're on square, you switch it to spike, you lose some signal amplitude, you could just make that up in gain. Here I've got a 1-inch Flawtech weld sample with a 5 megahertz 60-degree shear wave probe. I see a toe crack on the near side, and I've got the pulsar set to square, and I've set the reference gain to maximize the signal at 80% screen height. If I switch the pulsar from square to spike, I lose about 6 decibels. Is 6 decibels a big deal? Oh, well, depending on your application, maybe, but for most of us, no. If I just take that spike signal, I add 6 decibels back in and we compare the waveforms, it's basically exactly the same. There are special applications where I need to use a square wave pulsar, and one of them is the photoelastic camera. Here I've set up a 5 megahertz half-inch transducer, and side by side with the voltage on both the spike and square set at 250 volts, you can see just how much more oomph you get with the square wave pulsar. In order to make a nice image on that, I have to use square wave. But for most of all the other work I do, I don't really care. For most of what we do in the field with UT, whether that's thickness testing or weld testing, spike or square will work just fine. If you're using square though, you have to make sure that you've got the pulse width set correctly. On your machine, it may just ask you for the frequency, so you're going to set it to the nominal frequency of the transducer, or you're going to set it to half the period, which is one of these numbers over here. I hope you found this video useful. If you did, please hit the like and subscribe buttons, and thanks for watching.